Hello everyone! Today's video teaches how to use Pythagoras' theorem to find unknowns. Many of you have already heard of the Pythagoras theorem, but what actually is the Pythagoras theorem? This theorem is mainly used on right-angled triangles. If I asked you to draw any right angle right now, I believe there are a lot of objects in our daily lives which can help you draw right angles. For example, books, rulers, or almost any card inside your wallet. But back in the old days, there are no precision tools like we have right now. So when they need to have really accurate right angles, for example, when during construction, they need to find some kind of method in order to draw these really precise right angles. How do they do it? With just one piece of rope. First, they tie up this rope into lengths of equal segments. Using these segments, we have edges of length 3, 4, and 5. The opposite angle from the length 5 is exactly a right angle. There are almost an infinite amount of right-angled triangles in this world. Most of them, in fact, has decimal points in them. The number 3, 4, 5 that we used a while ago, because all three of them are whole numbers, they are really often used to make right-angled triangles. Therefore, the Pythagoras theorem we mentioned a while ago is used to express this relationship between the three sides. The longest side in a right-angled triangle, right opposite of the right angle, we call it the hypotenuse. And the other two sides next to the hypotenuse, we call them the shorter sides. So if we take each shorter side, square them, and add them together, it turns out for every right-angled triangle it equals to the hypotenuse squared. This is known as the Pythagoras theorem. We can try to use the numbers 3, 4, and 5 that we have mentioned a while ago in the previous example to see how we can use the Pythagoras theorem. 5 is the hypotenuse, and 5 squared is 25. 3, 4 are the shorter sides, so 3 squared plus 4 squared equals 25. For any right-angled triangle, no matter how long or short they all satisfy the Pythagoras theorem. For example, with this triangle with sides h, k, and 8. In this triangle, the longest side is the one opposite to the right angle, which is the hypotenuse. In here, it is 8. And the shorter sides are h and k. So according to Pythagoras' theorem, we can say that h squared plus k squared equals to 8 squared. Although Pythagoras' theorem, by the name, we can deduce that it is discovered by the mathematician Pythagoras, it has also been proven true in many other cultures by many other mathematicians. Some of these cultures and mathematicians have even discovered the Pythagoras theorem even earlier than Pythagoras himself. But since there are no historical texts documenting them, we therefore name this theorem the Pythagoras theorem. If you're interested in the proof of the Pythagoras theorem, feel free to watch this video from TED-Ed. There are both English versions and Chinese versions of this TED-Ed video. Now let us try to use Pythagoras' theorem to find the unknowns inside these triangles. Here we have a triangle with sides 30, 16, and a. Here we need to find the value of a. First we need to identify the longest side of this triangle, the hypotenuse. And the hypotenuse is opposite to the right angle, which is a. The other two sides, 30 and 16, they are the shorter sides. So using Pythagoras' theorem, 30 squared plus 16 squared equals a squared. Remember to write Pythagoras' theorem at the end of this formula. Then calculating it, we can deduce that 1156 equals a squared. Square rooting the answer, we have a equals 34 or a equals negative 34. And since we are using a physical side, a negative one doesn't make sense, so we choose the positive 34. For the next question here, we have a triangle of sides y, 2, and 3. Again, we first try to identify the longest side, the hypotenuse, which is opposite to the right angle. Here, it is 3. The other two sides are the shorter sides, 2 and y. 2 squared plus y squared equals to 3 squared, according to the Pythagoras theorem. Proceeding to calculate this formula, we can deduce that y squared equals 5. Moving the square to the other side using square root, y equals to positive square root 5 or negative square root 5. And since this is a physical edge, we choose the positive number. Y therefore equals to approximately 2.24. Corrected to 3 significant figures. That's all for today. If you have any questions, feel free to come to the math room or ask your math teachers. Bye!